In this video, we are going to deal with new concept of molarity, and we're going to see how we can use molarity with stoichiometry sort of put together. Remember what the definition of molarity is. Molarity is a concentration unit. It tells you how many moles of the solute there are per liter of the solution. So, given the following equation, how many milliliters of 0.569 molar hydrochloric acid solution is required to react completely with 3.45 grams of solid magnesium. This is stoichiometry, in which we're trying to go from grams of magnesium into milliliters of HCl solution. So let's map out how we're going to get from one to the other. We're comparing two different compounds. We're trying to get from magnesium to HCl. The only way you can compare two different compounds is through the balanced chemical equation in moles. So our first step is to get from grams of magnesium to moles of magnesium. We're going to use the molecular weight, the atomic weight of magnesium in order to get from grams to moles. This is straight stoichiometry like we've done previously. Then we're going to use the balanced chemical equation to get from moles of magnesium to moles of HCl. Remember, that comes from the coefficients. 1 mole of magnesium requires 2 moles of hydrochloric acid in order for the reaction to proceed properly. Now, there's no direct route to get from moles of HCl to milliliters of HCl solution. We've got to take one more step in between, and we are going to use the molarity. We're told that the molarity is 0.569 molar. That means that there's 0.569 moles of HCl in 1 liter of HCl solution. So we're going to use that molarity to get us to liters of solution, and then finally to get to milliliters, it's simply the metric system. So this is our map, and remember, in our map, each one of these is a conversion factor. It's one of our parentheses in our dimensional analysis. Molecular weight of magnesium, balanced chemical equation, molarity, and the metric system. So let's go ahead and set this up. We have 3.45 grams of magnesium. We're always going to start with what the question is asking about. The atomic weight, molecular weight, tells us that there's 24.31 grams of magnesium in 1 mole. The balanced chemical equation tells us that every mole of magnesium requires 2 moles of hydrochloric acid. The molarity for this particular reaction is that there's 0.569 moles of HCl in 1 liter of solution. And because we want our answer to be in milliliters, every 1 liter of solution contains 1,000 milliliters. Everything cancels like it should. Grams of magnesium, moles of magnesium, moles of HCl, liters of solution. We're left with our answer in milliliters. So the math comes out that we need a lot. 499 milliliters of HCl solution in order to fully react with 3.45 grams of solid magnesium.